Welcome everybody in Percona Live. So, today's topic is PostgreSQL and artificial intelligence. So, my name is Ibrar Ahmed. So, we will talk about some of the artificial intelligence, and initially was artificial intelligence, then we think about integrating that with PostgreSQL and the database. So, who am I? I have been in software since 1998 and I have 16 years of PostgreSQL experience. So, I have multiple books and my social media accounts are here. So artificial intelligence. So, I will discuss about the what is the artificial intelligence in some slides, and then we will go to the other part of that is a machine learning, deep learning, and have on a demonstration, and then we will discuss about the why we need a database to have a machine learning and artificial intelligence, how we can use a database to apply some of the artificial intelligence algorithms and something like that. So, artificial intelligence. So, the machine that mimic the conjunctive function that is human associate with the human mind, such as learning and problem solving. So, we are thinking from our mind. So, we want to computer a machine to learn like a human brain, to act some action, to perform some action. So, as a child he start learning from his childhood and his brain is trained to do some activities. So, we are performing the same activity to the computer to feed the computer the information, and that computer is start learning from that information and from that learning, and then it can decide and it can take action over that, similar to the human brain. So, artificial intelligence is no match for the neutral stupidity. It is Albert Einstein, and then a machine with AI is able to think and act like a human. It is able to learn from experience, so, and from the Einstein. I think the development of full artificial intelligence could spell the end of the human race. So, it is a mixed kind of attitude from the different leaders. So, the one who become the leader in this sphere will be the ruler of the world. So, it was just a quote. So, now we are going to the real artificial intelligence. So, there are three types of artificial intelligence. So, when thinking about there are first is called ANI, artificial narrow intelligence. So, what is the narrow intelligence? In narrow intelligence, if a computer can perform a single task. So, we will train the computer to perform a single task. It is much less than the human. Human can perform many tasks, but if a computer can perform a single task, something like Siri, the Google and something like that. So, it has a simple task, a single task that we will train it, it will perform a Siri and something like Google Ads, suggest us something that, but it is not acting, it is not performing a multitasks at one go. So, then in the middle is AGI, artificial general intelligence. Artificial general intelligence is like a human, because human is trained to do a multiple task. So, it learn from the environment, it learn from everything, from the data, everything it has in mind. So, it start performing the action. So, it is comparable to the human. So, the previous one, the ANI, artificial narrow intelligence, is less than the human, but the AGI is around almost the same, the human can act on that, the multiple tasks. So, ASI is artificial super intelligence. When we are talking about the artificial super intelligence, that means it can go beyond the human, because human can learn and act accordingly, but human does not accumulate large amount of data. Like if a computer has a capability of human mind and it has a huge amount of data and it start learning from data too, that it can act beyond the human. So, that is called, but we are not achieved, which system is not capable of doing right now, but the artificial intelligence are working to do that. It's dangerous, but it's beneficiary and it's dangerous too, because a human has a limited capacity of storage of data. Like you cannot remember that it's a bank transaction, how many bank transactions are in the bank, cannot remember. But if it has a capability, a computer has a capability of human mind and have a data of all the bank accounts detail, so it can act much more than that. So it's called artificial superintelligence. So ASI is a more capable than human, learning from past experience and from new data to be a variety of tasks. So that was the type of artificial intelligence. So then there are subfields of artificial intelligence. So it's artificial intelligence is a word, but it has subfields. So in which field you are working on that? The first one is the machine learning. So you feed the information to the machine and machine will learn from that and then it will act accordingly. So it's similar. A child when is born and grow up, you are teaching him to learn the language. You are speaking with him and start accumulating the data inside, and they will start acting and start speaking using that. So similar, the machine, you will feed the data into the machine and then that machine will act from its past experience, from its learning. So the machine learning. Deep learning is a bit of neural network. So it's a bigger neural network. So we will discuss it, what is the neural network and what is the deep learning next slide. So conjunctive computing, that it's also from the learning, so it's start learning, and then other field is natural language processing and computer vision. So artificial intelligence. So we will gather the data in first stage, then we just perform some cleaning stuff over that we clean, prepare and manipulate the data somehow. So have a clean input for our machine. So then we train our data. We train our model on that data. Then we have some test data. So we will test that, so how good our model is trained, and then we improve. So this is the cycle. So you gather the data, you have a bunch of data, then you clean it up, then you train your model, then you test your data and then you improve. So you keep going with this cycle. So ultimately you have a good model where you put some unknown data, so it will give you the proper result. So we'll see with example. So machine learning. So machine learning is a concept where you input your data and it will learn from data and it will act accordingly. There are three types of machine learning. One is the supervised learning, and other is the unsupervised learning, and then reinforcement learning. What is the supervised learning? In supervised learning, we have a data and we have a labeled data. Labeled data means we have data and we also have a result of that. Okay. So when we have a result, we trained our model on the data according to the result. So when we train the data, so data is correct. So like we have some kind of a data that we in a database and the result is true, and other row result is false. So we already know the result is true or false. So we will train our data that this data produce true or false. It can be any value, it will be in numerical value and something value. So we trained our data. So when we see that this row will produce true result and this row produce false result, so we keep putting this data into the model. Then where model is trained that this kind of a data always produce true and this kind of a data always produce false. So in that case, when you give that to unknown data and which will match the false or true, it will produce true or false properly, because it will train from its data and its output, that you have a result also. Like you can say that you learn in a college, you study different subjects. So you have a different marks, you are pass or fail, you are pass or fail. So it will learn from data you are pass. So, it will learn from data, you are fail. So, you continuously putting this information, because you have a query and you have a result. You have a data parameters and you have a result. You continuously train your data, and when you put unknown data where you do not have a pass or fail, something like that, it produce the actual result. There are chances of error there, but that is the way we train. And where it is we use it for the clustering. If you want to do some kind of a clustering of data, that's this data is this, like this is, we can have an example like this is a chair. This has the 4 legs and a top. These are the 2 properties of data. This is the 4 legs and 1 top. This is the property, and we have a table. Result in table, property is 4 legs and a top. And for the chair, we have 4 legs, 1 top and 1 back. So, we have a properties here. So, it is a chair. So, we are continuously putting this information and different information into that. So, whenever we put some kind of this information into the database, it will produce is a table or a chair. So, we will put every kind of a data where we already have a result of that. That is called a supervised learning. It is similar to the child. When you trained your child, that you said that this structure is a table. So, the child will remember this is a table, and you said this is the chair. The child will remember this is a chair. So, when you ask what is this, he will say this is a table, this is a chair, because you are supervising him in that case. So, regression and the clustering is the main objective of that. And unsupervised learning. In unsupervised learning, you have a data, but you do not have a label. You do not have a label. Like you know that this has the property, but you do not know what is this and what it produce. So, you put this kind of a data and you get the result. So, how you get the result? Most people are confused. If you do not know the result of that, how you can produce that? It is used for the association. Like if you go to some mart, you buy bread, right? And then you buy eggs, then you buy milk. So, it will create an association between bread, eggs and milk. So, whenever a person buy a bread, he usually buy milk, he usually buy eggs, and somebody buy a meat, he has some spices. So, it will create an association between the objects. So, we do not know what is this, we know this is something, it is egg, we do not know it is egg something. So, what is the benefit of that? So, when we try to learn from this, we make the association. That is why the grocery store usually put the bread, the egg, the milk in one side. So, whenever somebody grabs a milk, he will definitely grab bread. It is not 100%, but it will create an association. So, in a mart you have a different sections. So, it will attract the people. So, like if you do not have an association, you have a milk there, you have a bread there. So, usually somebody have a milk and he will go out, but he will say milk, oh I need bread. So, you just pick the bread there and you will get out. So, this is the marketing strategy. How it is learned? It is a unsupervised learning. We are not supervising, we are just learning from the data. The machine is learning from the data that persons are buying similar kind of things, and what is the thing? So, just put that things in that area. So, this is called the reinforcement, unsupervised learning. So, we are not supervising, we are not telling what is this, but previously in supervised we are labeling the data, that this data is this data has a this property, this data has a this property and this result. That is a label. Unsupervised, there is no label on that. Then the reinforcement learning, and the reinforcement learning, you have you can say that is a hit and trial. Like you are going somewhere, like you are going from here and you see there is a wall, you come back, you go to side, there is a wall, you come back, there is a wall, and you come here, there is a wall, you go there, there is a door. So, when it's try to learn from this, so next time he wants to know where is the door, he knows there is a door, and that side there is door. We do not want to go to the left, do not want to go right, back, front. So, it is sideways, there is a door. So, it will learn this is the basic of robotics. So, usually you see the child's cars, they usually go and just stop because there is a wall there, just stop there, but it is only a data. If there is a machine learning algorithm, next time they will not go and touch the wall, they will go direct to the door, because they do not have an algorithm, they only have a data, but they have no algorithm there. So, this is the basics of the robotics. So, these are types of machine learning. And the deep learning is a neural network with more layers and modules. It has a model which can take any input output type of the size. In this case, this is the neural network example. So, I will go and next slide is deep learning is a neural network, because neural network and deep learning almost the same thing. Is the base is the neural network, and the deep learning has a more layer, something like that. So, you in this case you do not have some kind of a properties of thing, like I said that there is a 4 legs and top and this. So, you need to you are providing this information to the machine learning that this has a top, this is a 4 legs something, but in neural network you have to extract that information too. Something like you have 3 input here, and these are the input node layer, and then the hidden layers, and then the output. So, it will input, it is like a human neuron, the brain has a neuron. So, how the neurons act like. So, we input the data and they calculate the weight and everything, and that put the resultant value to the hidden layer, and hidden layer to the next hidden layer. So, next hidden layer, because here is the only one hidden layer, but it can be the multiple layers here. So, ultimately if it is close to the output 1 or close to the output 2. So, I will give the example here that if you have recognized 1 to 10 number, 1 to 9, it is a 0 to 9, sorry, it is a 0, 1, 2, 3, 4, 5, 9. So, that means you have a number and you have to recognize it is a 0, it is a 1, it is a 2, it is a 3, what it is. So, when you input the data 1 in the hidden layer, it will cut down the portion of your number 1. Suppose we are only 2 layers. So, we are cutting down the number in 2 shapes, like 1 we cut it the half 1 half 1. So, we pass that information to the next layer, and next layer will decide that if you have a 2 stick, so it is a 1. So, if you have a 2, so we divide that 2, we have a 2, I do not have on a board here, I will explain that. You have a 2, so we cut in between, so half portion this or half portion this. So, in the next layer we will decide this is a 2. So, if we have another layer, so we will cut 2 half portion again, this is the 4 parts. So, that this and these properties it had, it is a 2. So, something like that, when we train that, the neural network will run continuously running and we have a model ready. So, whenever you put 2, it ultimately said it is a 2, and said 3, it will say it is a 3. So, we trained continuously. So, it has a many algorithms in between the back propagation, in back propagation and forward feed. So, I am not discussing all of these, because there are a lot of stuff in the neural network and deep learning, because in back propagation you are getting the result. If the result is not correct, so you just come back to the input, then again change the weights and you can get the data again. So, you continuously doing that. So, ultimately you get the final result. So, you trained your model, then when you put unknown data, it will extract. So, what is the difference between the machine learning and the deep learning? You know that why we 1, 2, 3 we put it that we have not provided any information there. What is this? But in the machine learning we said that it is a 4 legs, top, everything we are providing this. But in this case we are extracting the feature of the thing within the model. It is part of the model to extract the feature of the input and then produce the result. So, here is the as a deep learning. So, you can see there are multiple layers, multiple models are here. So, you can see that here is the pictures of persons, right, of many persons. So, you want to recognize who is he or who is she. So, in first pattern we just grade scale that every information, and you see that there is the eyebrow, there is something like this. So we extract the information from these pictures. This is not one input, it is the multiple inputs. So when you put one picture, so it will compare that who has this kind of eyebrow, eyes. So it then divided that into lips, nose, it start cutting the portion and said that a person has a wide nose, a thin eyebrows and long hair is this one. It will start deciding, but it will not say that the output is this. So you can see ultimately you have the face of that, and the output layer it will recognize that this person is this. If you put the picture, it said this person is this. So it extracting the properties of input. In machine learning, we are providing that, but the deep learning or neural network, it extracting the information from the input and then generating the model, and when you feed the unknown data, it will produce the proper result. So here is another example, the machine learning. You input, you extract the feature. It's a human is extracting the feature, not the machine. Then you do some classification, classification or whatever you want from the machine learning. So car, not a car. So you provide, it has a 4 wheels, it has a body, it has a steering. So you are providing this information. So he said it's a car or not. So he said it's a 2 wheel. So it's not a car. He said it's not a car. But if you provide 4 wheel, it's a car. So you are providing the information. But in a deep learning, you input the car only, and it will say it's a car or not. Yes or no. It will extract the feature from the input and then classify it and said it's a car or not a car. So we are not providing any information there. So here is actually is from the Bruce talk. So he has provided the talk some months ago. So I have got the courage to ask him to give me the example from this. So I got it from him. So it's from, so I have to give the credit that he wrote this example, because this is a basic simple example. So you have a number, and you want to look at that this number has a 0 or not. For looking at that, you can see, oh, first one is true, it has a 0, and second one is false, because of the human mind. The human is detecting that there is a 0 or not. So the other way is mathematics. You can perform some mathematics, and you can get this as 0 or not, right? You can do a string processing, and you can see there is a 0 or not. But we are not going in that detail, because a simple example, there are other ways. But in some cases, you don't have on a mathematical solution, you need to learn from that data. So here multiple solutions available, but we will perform artificial intelligence to detect it has a 0 or not. So see, you can download the complete example from Bruce website. So it's all the examples are there. So you will get the slides. So I also provide the link of slides. So from slides you can get this information. So the complete example you can run it yourself. So there are two things. One thing is that PostgreSQL have different languages too, like PL Python and PL Perl, and PL Python is really good. Not PL Python. Python is really good for the artificial intelligence and machine learning. They have bundle of APIs available to perform the artificial intelligence. So it's good thing that you can do is a Python. But in Python, if you do that, you have on some API, you just put dot artificial intelligence neural network, it will produce the result. So you can't see what's going on behind that. So that's why I am happy that he has provided the Perl example, where he himself performs some tasks without using the APIs. Otherwise, API is just 1 or 2 functions: input data, generate model, test data, and that's it. So it's 3 lines here. So there is nothing new for you to learn here. But he did that using the PL Perl. So a tensor is a data structure. which can hold, actually tensor is a word used here to store the vector and the values, the scalar, the way to store the data. So, we usually call in artificial intelligence it's a tensor. So, we will generate a tensor. So, I am literally not going into the detail of PL-PAL. This is the example for you to try. I will explain overview of that. So, you turn the, because it's quite a complex PAL things are here, but it's really good to you try it and run it, and it will generate the result. So, we generate the data structure for that, and let me show you the I have the data of that. I think no, this is not data. So, what we are generating, wait for the tensor not, yes, this is the in the next slides. Okay. So, we generate a tensor, we generate a data structure for that which can hold the values, like values is 1, 2, 3, 4, 5, any value it can hold, and it is set true or false, true or false. Okay. So, like 1, 2, 3 false, there is no 0, 1, 2, 3, 0, 4 true. So, it can hold this kind of a data, it is called a tensor. So, we will create tensor, it's you can do a simple creating a structure there. So, it does not matter. So, but they are calling it a tensor. So, we are also calling it a tensor. So, I told you that there are some processes to do some machine learning, like we will train our data, right. So, we need a training set, like we have 100 inputs, like 100 inputs, like 1, 2, 3 or 100 inputs. We know that we have 100 inputs. So, from a portion of that, like 70%, 80%, we give that to a training set, like 80 values we will get to our training set. So, we will generate a training set, because we are generating ourselves. So, because we should have some data. So, we have 80% of our data as a training set. So, what is the training set? Training set will be 1, 2, 3 false, 1, 2, 3, 0, 4 true, 1, 0 true, 2, 4 false. So, we have this kind of a data 80%. We have 100% of data, but we only extract the 80% of data randomly from there. So, then we are generating the random integer. So, we have a different values, not 1, 2, 3, 4, 5. So, that is true. So, here is the input. So, we have a training output. So, like you can see that there is a value and true, false, true, false, true, false, and the true and training set. I am just limited to 10. So, we have a data, and then on data we training data, and then we need to test data. So, we have a data. So, we 80% we give that to the training data, and 20% give to the test. So, model will be trained on 80% of the data, and 20% of the data will be used to test our model. So, when this 100% is done, then our model is ready. According to that 20% test, how percentage accuracy it has. So, we have 80% of data used for the training, 20% of our data for the test, because in 20% we will not provide true or false, we will not provide the result, we will provide only the numbers, and it will say it is true, false, true, false. So, we will compare it to the actual data, and we will get the error, how much error it has. So, here we are we need to generate some weights for that. So, generate weighting and neurons. So, like an example here, in this if you see that every neuron, so when passing to the other layer, it will be multiplied with the weight. Initially it can be any weight, 1, 2, 3, any weight. So, you can provide that, but when this model is getting trained, we are keep changing our weights there to get the perfect result. So, ultimately we will get the final weight of that. So, that is because it will be really long. If I just giving the mathematical example to differential, we create the calculate the differential, how we calculate the error function, and then weight subtract the minus subtract the weight from them. So, it will be very long. So, training set is an input layer, weight we have generated the weight, we generated the weight for the multiplication, and that you can look at that in detail. For tensor mask and some weight, I just want to show up you the result. So, we need to store the results also separately. We need for the training set, we are storing the data and the result same, but for the testing model, we need only the data and the results. So, we are storing separately, because we will in that testing model, we will not provide the results. So, we will have a separate results for that, and then we will calculate that result with the generated result from the model. So, we will compare that and we will see that how much error we have in our model. So, here is some tensor weight true or false. So, you get that in which you have a false or you have a true in the table. So, we are testing 100. So, you can see that the result is 0.077806133. The result is not really good, because it says it has a 0, it says is a 0.22%, or you can percent or 1 you can multiply by 100, the 22% chances there is a 0. So, model is not really well trained. It's said 77%, it has a 20 and still says it's a 22% chance there is a 0, and 77% chance there is a no 0. So, that means our model is not very well trained, because we have provided only the 100 values or 20 values or 30 values. It cannot be trained with this kind of value. If you have a 1 billion records, so you provided that records, how big your data is, that's accurate your results. So, like if you give some 4 or 5 words to your child and you are expecting him to speak English or some language, it is not possible. You have to give him enough data to speak one language. So, that is a similar, we are providing a very small data set and we are expecting that it will produce the right result. No, but it is an example. So, if you give them the more data, it will start you getting the proper result. So, you are getting a 0.22% will be increased gradually. So, when we will put a threshold that is even 80% or 90% true, that means our model is 90% accurate. Now, our model is 22% accurate. It is not good, but we provide more data, then it will be changed itself. So, you do not need to change your model will be the same. The important information is the data, you provide the data. So, these algorithm I just showed you, it is just in Python you have one function or two function, input, generate model, output, test, train, that is it. But here you can find the example here. So, you do not need to change your model. So, here we have testing the 101. In 101 we have only 10. So, you can see accuracy is again 0.11%, 11%. So, and another decrease in the accuracy, because previous one we have a 2 zeros, I said it look like we have a 0 there, because there was a 2 0, but here we have a 1 0. So, accuracy is also decreased. That means we do not have enough data. So, look at this, we have almost the same result we are getting continuously, that this value 487234987, does it have a 0? It says 68% chances there is a 0. It is quite funny, because where there is 0 it is reverse. That means our model is not accurately trained. We do not have enough data to train our model to get the perfect result. So, you are keep training your data, you get, if you get the 90%, 80% or whatever your requirement, you will get the proper result then. So, then I have a test set. So, now we are generating some random number and then generate the series and start putting that into the testing. for the 1000 value. So, see what is the accuracy we are getting here. So, that table expression. So, here you can see that the check value 6, it has many numbers. So, I am not 1000. So, I just have a 8 to 9 here. So, 6 is a false. So, 6 is the data and f is the over its false or true, it is a result. So, in output layer we are getting 029 and 097, the accuracy at 0.47, accuracy is 0.47. So, similarly, we have all the data here on the left side, we have the actual result, we have not fed it this result, the CMP bool we have not provided to the system. We know that this is there, but it will calculate. So, you can see the accuracy is not really good, but somehow it is good, somehow it is not good. That means, how much well trained your data is, you will get the accuracy much better in numbers. So, I am not here to produce the best number here, it is just an example. So, it can be the worst number, that means your model is not trained. Trained it more, so you will get a better accuracy number here. So, from the demonstration we have seen that we can involve database to get the machine learning or artificial algorithm to running. So, what people are doing actually? Machine learning, artificial intelligence, or this required a lot of data, because in this example we have seen that we have only 100 or 200 values from where we are producing the result. So, lot of data. What actually the machine learning people are doing, what they are doing, they are exporting the data into the CSV file, because they have a separate library for the machine learning. They are putting the VACA or something Python library, they are putting in CSV file there and then generating the data results. So, why? We already have a data in our database. Why are you exporting that data into the CSV and then putting in the library? So, the main purpose of this, you use this data which is inside the database to produce the machine the results using the artificial intelligence. This is the one thing, to use actual user data to produce the result without exporting to the external tools. The second benefit of that, to using database, you can use the artificial algorithm to have a performance benefit from the database. Like for example, you can have a data, you can have a statistics, you have everything. You can perform the machine learning algorithm on that data to produce the better results. So, similarly, I was researching on that. So, I will also discuss with Jim that transaction wraparound. So, usually it happens, transaction wraparound thing. So, people do not know when it happens. So, I am writing a research paper on the machine learning, that we will learn from the data continuously to predict, forecast when this transaction wraparound will occur. So, like it will put a graph that it will, if you have a 1 year of data, is continuous reading that 1 year, 2 days and 10 seconds, it predicts that it will wrap around. So, be careful about that, maybe next week. So, we already have this kind of a data in a database. So, one purpose for the user data. So, user data do not export to the CSV file and get the machine learning algorithm work, do that within the database. The second thing, use the machine learning or artificial algorithm for the database performance and prediction or something. So, use the previous activity as a training data, like you have 10 years of data in your database. So, use it as a training. So, train your data for last 10 years, and for 1 year just look at the test your model. So, you have plenty of data, 10 years behind you have a training data, or 1 year you are testing data. So, you can get the very good accuracy. So, you can predict the next value. So, if you want to do that using exporting, so you need to export the 10-year data into the CSV file, go to the Python library, just input that, get the result, put the result back. So, after 1 month you need to do that again, extract that again, but you can continuously do that. And again take immediate action, like if you are not exporting that, you can take the immediate action if something happen, like commit transaction only if likely not fraudulent. So, you detect, you have an algorithm built into your database which will detect that this transaction is fraudulent or not fraudulent. So, on previous record that you have a record of 10 years that this activity looks suspicious, do not commit that right away, but if it does not look suspicious, commit it. So, otherwise exporting the data to the CSV, you cannot do that, but if you are within the data, you continuously, your model is training, continuously training your model. So, you are keep updating your fraudulent information model there. So, it will detect is a fraudulent, is a not fraudulent. AI can benefit from database transaction, concurrency, backup. So, you are taking the backup, everything, because it is all about the data. Why we are not storing the data into the database? Machine learning required data in database should be in the database. Other benefits includes complex data type, full text search. So, everything we already have that. So, we can benefit from that. Postgres can do a GPU based computation inside the database. So, there is another talk is available from Boost that it has some slides about the GPU, how to use that. So, you can benefit that. So, here link is here in the bottom of that. So, how much time we have? So we have a user application. We discussed that we benefit of that, but the user application performance adjustment in database, we can do some performance adjustment with your database. Optimizer plan, because we have a statistics. We have a statistics performance lost many years, maybe a lot of data is there. So, you can do optimizer plan, you can optimize that. Index creation and destruction, database settings. So, what is database setting? Like you set the shared buffer, example shared buffer, and you are continuously performing some machine learning algorithm that you required more or less. It will predict for you that you required more shared buffer or less. So, you tune your configuration settings based on that algorithm. Then resource usage, you continuously monitor your resources. So, it said that this is this peak time, that usually you have a peak time on a Friday night and you do not have any peak time on the weekends. So, it will also predict the days and something like that, where the resource is mostly used and which days, at what time. So, you can manage your resources. Alerting, definitely malicious activity, fraudulent activity. You have a model, because everything is model. When you train your model to detect the malicious activity, so whenever some malicious activity come, it will say, okay, stop it, it is a malicious activity. So, you can alert that resource exhaustion, like it can also predict that when your disk will full. So, it will alarm you. So, it just alarm that it is going to be full in next week, 1 month, something like that. Not amount of MBs. It is possible you have 100 MB left, but you are not doing anything. So, 100 MB is enough, but you have a 10 GB left, but your the system detected it will be expire in next month, it full in 1 month. So, you have to add more, or you just clean up your previous data. That is it. Time. So, question. Yeah. All talks are available here on GitHub page. All talks are available here. So, these talks, the Austin one is available on GitHub page. Yeah, just you go and download there. And for the examples, even example are also pasted here, but if you actually go to the Bruce, I also put the link of that Bruce site. So, you can download the code from there, but code is also in the presentation. So, we're good. Yep. Thank you, everybody.